Good morning, students. Today we are going to start the most tough topic in O levels chemistry, that is organic chemistry. So concentrate yourself. This is the lecture number 1 of organic chemistry. Fuels. The sources of the fuels. First source is natural gas, and second source of the fuel is petroleum. The main constituent of the natural gas is methane. And here is the structure of the methane. The carbon atom is in the middle of the tetrahedron with hydrogen atoms at each of its corners. Here is carbon and here are hydrogen atoms. And this structure is tetrahedron in a 3D solid figure with 4 faces. Methane burns with a blue, non-luminous and non-smoky flame to liberate a lot of the heat energy. And the reaction is here. CH4 plus 2O2 forms CO2 plus 2H2O. And the heat energy given out is 882 kilojoule per mole. This is an exothermic reaction. Petroleum is a mixture of the hydrocarbons. In the refinery, petroleum is separated into separate fractions by fractional distillation. Petroleum fractions are important source of energy needed to run our homes, hospitals, and factories. Petroleum fractions such as naphtha are the main sources of the hydrocarbons used as the feedstock for the production of the wide range of the organic compounds. Methane, also called natural gas or North Sea gas, these are the alternate names of the methane, is formed when plant and animal matter decays in the absence of the air. It is found in coal mines where it can cause explosions. The methane generated in landfill rubbish sites and sewage works can be utilized as fuel. Some countries set up biogas generators to make biogas from human, animal, and plant waste. The next topic in the lecture is homologous series. Very important point, so concentrate yourself. A homologous series is a series of the organic compounds with certain general characteristics. Each member of the series can be represented by a general formula. Successive members of the series differ by 1 unit of CH2 or 14 units because CH2 forms 14 units in their relative molecular mass. All members of the series have similar chemical properties. Their physical properties change gradually with increasing relative molecular mass. All members of the series can be prepared by a similar method. All members of the homologous series have similar chemical properties because they contain the same functional group. Each and every point is very important, students, so concentrate yourself. This is the most tough topic in chemistry O levels. A functional group is a special group of the atoms that determines the chemical reactions of a compound. Table below shows some common functional groups. This group is alkene. This is alcohol group. And this is carboxylic acid group. These are some very common functional groups. The next topic in the lecture is naming organic compounds. The first part of the name of an organic compound indicates the number of the carbon atoms it contains. The number of the carbon atoms in the compound is indicated by the following prefixes. And here are the prefixes which you have to learn. 1 stands for meth, 2 for eth, 3 for propane, 4 for butane, 5 for pent, and up to so on. The end part of the name indicates the homologous series of the compound. This is the functional group and this is the second part of the name. This group stands for ane. Double bond, if there is double bond in the compound, this stands for ene. If there is this functional group, it stands for ol. And if there is this functional group in the chemical formula, this stands for oic acid. Carbon atoms can bond together in so many combinations that there are more compounds formed by carbon than by all the other elements put together. Very important point. The reason for this are carbon atoms can. This short question frequently come in the paper. What are the reasons that carbon makes so many compounds? The reason are carbon forms 4 bonds. Carbon atoms can form strong bonds with other carbon atoms. And carbon atoms can form chains of the atoms. This property is called catenation. Hydrogen, oxygen, and nitrogen atoms often join to carbon chains. These chains can be almost any length. A different number of the atoms in the chain means a different compound. A number of the carbon atoms in a chain is called the chain length. Long chain carbon compounds are found in all living organisms, both animals and plants. Some common examples are shown below. This is a compound of hemoglobin. This is found in blood and it contains a carbon chain of 5,000. Starches, which is found in animals and plants, chain length is 300 to 10,000. Cellulose, found in plants, the chain length is almost 20,000. Because so many carbon chain compounds are found in living systems, organisms, the chemistry of the carbon chain compounds is called organic chemistry. There are so many carbon chain compounds, the study of them can be very confusing unless you have 2 important ideas clear in your mind. The first idea is the length of the carbon chain in a compound controls most of its physical properties, such as melting point, boiling point, and solubility. Compounds with short chains are gases or liquids that boil easily. Compounds with medium chains are liquids. And compounds with long chains are solids. The types of the link in the chain or at its ends control the compound's chemical properties, that is, what it reacts with. So this was the lecture, students. Hopefully this will be very helpful for you. Read it again very carefully and make your notes. Thank you so much.